The Autoland system available on the Embraer jets allows operations with decision heights not less than 50 feet height above touchdown zone and runway visual range not less than 700 feet, Cat 3A, or 600 feet for Cat 3B. Autoland certification also requires compliance with Cat 2 requirements for the portion of the approach prior to 100 feet height above touchdown zone. The system is certified in the fail-passive classification, that is, in the event of a failure there is no significant out-of-trim conditions or deviation of flight path or attitude. Autoland 1 implies that the system is capable of performing an Autoland without rollout guidance. Autoland 2 implies that there is capability to perform an Autoland with rollout guidance to a safe taxi speed. To satisfy the system logic and to arm or engage the Autoland mode, some hardware and operational software are required. Check the minimum equipment list before performing an Autoland procedure. The yaw axis function is an independent function controlled by the AFCS and is provided on Autoland-equipped aircraft through a parallel rudder servo. The yaw damper is required to arm or engage the Autoland. When Autoland engages, the parallel rudder servo is tested by commanding a small and slow movement of the pedals in both directions. Loss of this rudder servo will result in loss of the Autoland capability and of the autopilot. The rudder servo failure causes the autopilot rudder not available message to latch. The failure is only reset on the ground by a successful electrical power-up. During Autoland operations, the automatic pitch trim adds a nose-up trim bias into the horizontal stabilizer trim command at 800 feet radio altitude in order to prevent a nose-down transient in the event of an autopilot disconnect during flare. Also, automatic pitch trim commands are inhibited during flare, derotation, or rollout. When the airplane powers up, the Autoland is enabled by default. You can disable it via the MCDU. Press the menu button to get the associated page. Press Line Select key 1L to go to Miscellaneous Menu page 1.1. Now press Line Select key 2L to access the Setup page 1.1. Line Select key 4L allows disabling and enabling Autoland again. The operational conditions to arm Autoland are: Autoland is enabled, autopilot and yaw damper engaged, RA baro set to RA, and minimum set at 50 feet. Lock 1 nav source selected on one PFD and Lock 2 on the other PFD. Both PFDs set to correct lock inbound course. No miscompares on PFDs. Both nav radios set to correct lock frequency. When Autoland is armed, that is, all of the previous conditions satisfied, the FMA will show a white Autoland annunciation. To engage the Autoland mode, flaps must be at 5 and both radio altimeters indicating less than 1500 feet and greater than 800 feet. Once both conditions are satisfied, the Autoland annunciation will change from white to green. There are no additional controls for specific Autoland operations. Instead, some existing controls incorporate new functions and logics. Autoland operations can be carried out either in Cat 1, Cat 2, or Cat 3 conditions, even if one engine is inoperative. For Cat 1, select the RA barrow knob to barrow after Autoland has been engaged. For Cat 2, select the RA barrow knob to RA and set it to 80 feet. For Cat 3, select the RA barrow knob to RA and set it to 50 feet. The Autoland annunciation is shown on the FMA in white when armed and green when engaged. Retard, align, flare, rollout, and derotation follow the same standard. White when armed, green when engaged, and are shown on the FMA as well. Some controls are inhibited when Autoland is engaged. The push buttons for source selection, lateral modes, speed modes, and vertical modes including nav, heading, approach, bank, source, indicated airspeed MAC, VNAV, felch, alt, FPA, vertical speed, flight director buttons, course selection knob, and the touch control steering button. The ICAS messages related to the Autoland system are Autoland not avail, displayed to indicate that Autoland is not available due to the lack of required system elements. Autopilot rudder not avail, displayed to indicate that autopilot rudder control is not available. Autoland off, displayed to indicate that Autoland was deselected via the MCDU. Loss of Autoland engagement results in a red No Autoland flashing annunciation and a No Autoland oral warning in cases where the autopilot remains engaged. This will cause the Autoland modes, align, flare, derotation, and rollout to be removed from the armed active FMA fields. When appropriate, an amber flashing DH setting on the PFD will also be displayed. Loss of Autoland with an additional autopilot disengagement results in a red flashing autopilot annunciation and an autopilot oral warning instead of the No Autoland annunciation. In both cases, the visual and oral warnings can be cancelled by pressing the autopilot quick disconnect button. The No Autoland annunciation is also cancelled if a go-around is initiated. Any reversion from Autoland will degrade to the highest capable non-Autoland category flight director mode. Localizer and glide slope miscompares will cause the reversion from LOC GS to FPA roll. While performing an Autoland operation, guard controls from approach to touchdown and be prepared to take over manually if required. Anticipated and appropriate pilot intervention will be necessary in any case, preventing the aircraft from safely landing in the touchdown zone. When an Autoland is planned, additional preparation is required. Considerations like crew qualification, destination airport meeting CAT 3 requirements, equipment required, fuel and weather must be taken into account before dispatching the aircraft. Flight crews must remember that when ILS critical areas are not protected, ILS beam quality may vary due to vehicle or aircraft interference. That is supposed to happen when weather minima are not CAT 3, but CAT 3 restrictions are not being followed. Therefore, when training Autoland operations in CAT 2, CAT 1 or visual conditions, closely monitor Autoland performance and be prepared to disengage autopilot, manually land the aircraft or go around. Check that available landing distance is consistent with the calculated performance and the associated runway condition. CAT 3 landing speeds should be used throughout the whole Autoland approach, despite of the actual weather conditions. The crew should check that tower wind is compatible with limits for CAT 3 approaches. Pilot eye position is crucial during low visibility approaches. Be sure to adjust seat height to the best position as reference to the level spheres installed at the windshield partition. During the approach, the pilot flying primary tasks are supervising and decision-making, while pilot not flying is monitoring the operation. Pilot flying will be head-up, guarding controls, and continuously ready to take over. He or she will take the appropriate decision in case of failure and at decision height. The pilot not flying will be head down and monitors FMA, any failure, and aircraft trajectory. Check how a normal approach with Autoland and autothrottle engaged is like. Prepare for the approach and perform the approach checklist. Set the speed selector to manual and set the airspeed bugs. Set the RA barrel outer knob to RA and adjust 50 feet on the ADI window using the inner knob. Auto brake armed is required for Autoland 2 approaches. Check the following conditions are satisfied. Autoland enabled via the MCDU, autopilot and yaw damper engaged, lock 1 on the PFD and lock 2 on the other PFD, both nav frequencies set to the same correct lock frequency, both PFDs set to correct lock inbound course via the course knob, and no miscompares on the PFDs. Press the approach button. Set flaps to 5 upon capturing the glide slope. The highest priority approach mode available will arm. If Autoland is not disabled and the MCDU and all requirements to arm are satisfied, you will see a white Autoland 1 or 2 annunciation. Expect the Autoland to engage when radio altitude is between 1500 and 800 feet and flaps are at 5. Confirm it by the green Autoland annunciation. Follow tightly localizer and glide slope in a stabilized flight. Monitor airspeed closely too. Rate of descent will be consistent with the glide slope beam angle. During final approach, the parallel rudder system logic applies a crosswind landing compensation until 150 feet. Below 150 feet, the align mode is engaged and a decrab maneuver is performed to align nose with the runway heading. The pilot not flying should be monitoring and call out for the go-around in case speed is 10 knots above the target speed and 5 knots below target. Vertical speed is greater than 1,000 feet per minute. Pitch is greater than 10 degrees or less than 0. Excessive localizer deviation greater than 1/4 dot. And excessive glide slope deviation greater than 1 dot. At 150 feet radio altitude, the align mode automatically engages and the rollout mode arms. Approaching the decision height, the pilot flying starts to look for visual references. He should come to this altitude prepared for a go-around. In Cat 3A, Autoland 1, the visual condition required at decision height is that there should be
40,
references that
30,
confirm that the
20,
aircraft
10.
is over the touchdown zone. Go-around is mandatory if no visual reference is confirmed or a failure occurs. It means that for JAR ops, 3 light segments of centerline, or the centerline or the touchdown zone lights, or the runway edge lights are in view for the fail passive system installed on the E-jets. For Cat 3B, Autoland 2, the visual reference must contain at least 1 centerline light. At 50 feet radio altitude, the flare mode automatically engages and derotation mode arms. Check that flare begins at the right altitude and the correct attitude is held through touchdown. Normally about 2 or 3 degrees will be enough for a good flare. At 30 feet radio altitude, the autothrottle retard mode engages. Check that thrust reduces reasonably slowly so that idle is reached at touchdown. Remember, rapid thrust reduction may result in downward pitch tendency, which might also result in increasing pitch attitude at touchdown. At main gear touchdown, rollout and derotation modes engage. Check that centerline is maintained while nose is lowered to runway. Check also that autothrottle disengages normally. The Autoland should perform reasonably. It should land in the touchdown zone. It tends to favor a firm touchdown over touching softly, which is quite reasonable mainly when landing at contaminated runways. The flare is fine-tuned so that it should not be a hard landing, no floats nor bouncings. Nose gear should also land in an average rate. Touchdown should happen at approximately VREF, and your landing distance will be consistent with that. On the Autoland 1, the autopilot will disconnect automatically 5 seconds after transitioning to rollout and derotation. However, it is recommended that autopilot be manually disconnected as soon as nose gear touches down. The Autoland 1 status is removed and the flight director modes and cues are removed. The autopilot visual and auto warnings are initiated. The pilot must then take control of the airplane, proceeding to the deceleration with manual or automatic brakes, maintaining runway centerline and applying reverse thrust as required. On the Autoland 2, landing rollout through a safe taxi speed is controlled by the autopilot. Autobrake will decelerate the airplane, and reverse thrust is available for manual application. If not disengaged before, autopilot will automatically disengage at 12 knots of ground speed with a corresponding visual and oral warning for the autopilot disconnection. We emphasize the relevance of the safety and automation interface. The optimum use of automation requires knowledge of system design, understanding functional displays and controls, situational awareness, and strict adherence to standard procedures. Effective monitoring and proper corrective action is essential if the flight crew confronts an automation exception. Alertness to revert to a lower level of automation is achieved by training and qualification of flight crews when the goal is to increase the safety and efficiency of flight.